All right, and we back with section 8.3.9.3, geometric sequences and series. So up top in the notes it says, we have learned that a sequence whose consecutive terms have a common difference is an arithmetic sequence. Right, which is the videos I just did for 9.2. Geometric sequences, on the other hand, have a common ratio that link the consecutive terms. So instead of adding or subtracting a certain number to get to that next term, we're going to multiply our current term by another number by a common ratio to get to the next term. So let's look at the definitions here. Definition of a geometric sequence. A sequence is geometric if the ratios of consecutive terms are the same. So that goes back to that ratio again. So the sequence A1, A2, A3, A4, A to the n is geometric if there is a number R such that, and let's pick this apart real quick to make sure we all understand it. A2 divided by A1, so the second term divided by the first term has to be equal to the third term divided by the second term, which also has to be equal to the fourth term divided by the third term. And so there's this relationship of a proportion or a ratio that goes between each term now instead of a certain amount of values like there was when we were adding or subtracting. So the number R is the common ratio of the sequence. So the term divided by the previous term, if those are all similar with the whole sequence, then that number, whatever second term divided by first term is going to be R, because that R is going to be the same whether it's second term divided by first term or a millionth and first term divided by the a millionth term. So that R will be the same no matter what. So that's what we're going to refer to as the common ratio. So I'll write that up here. Common ratio. Make that a little more clear. And so the nth term of a geometric sequence, the nth term of a geometric sequence has the form a sub n equals a sub 1, so the initial term, times r to the n minus 1. So let's pick this apart like we did with the arithmetic sequence. So a sub n is the nth term. So term we're trying to find. Not always, but usually if we're finding the nth term, that's the term that we're trying to find. Usually they don't give us an nth term, we're solving for an nth term. But a sub n is going to be the term we're trying to find, or the unknown term, or whatever term it's asking us for. So a sub 1, just like with the arithmetic sequences, is going to be our initial term. R, as we said, common ratio. We'll just keep that right there. So we've got a sub n, a sub 1, r, and n is going to be the number of term, right? So term number. And then we have minus 1 right here to signify that we're taking the common ratio to the exponent of the term number minus 1. And let's see why that works here. So if we're looking at the first term, a sub 1, we're going to multiply a sub 1 by r to the n minus 1. If r is any number, I mean, we can name it number 5 billion, we can name it number, we'll go with x for now, so number x, okay? So a to the first times x, and then n, since we're just looking for the first term, n is going to be 1. 1 minus 1 is 0, right? So we have x to the 0 right here. Anything to the 0th power is going to be 1. And so this whole term right here is going to turn into 1. which means that the first term times r to the n minus 1 is still going to be the first term. And so we can see that this formula will work, obviously, with the second term, third term, and so on, as long as there's that common difference of r, or the common ratio is r. So the nth term of geometric sequence has the form a sub n equals a sub 1 times r to the n minus 1, where r is the common ratio of the consecutive terms of the sequence. So every geometric sequence can be written in the following form, and this is just another way to memorize or to write out the entire sequence. So you can have the initial term times r times n minus 1. Wait, no, sorry. Your first term will be a minus 1. Your first term will be wow, I butchered that. Okay, so your first term is going to be a sub 1 because that's your initial point. Your second term will be a sub 1 times the common difference to the first, right? Because right here it was technically a sub 1 times r to the 0th. Now it's going to be a sub 1 times r to the first. The third term is going to be a sub 1 times r to the second. Fourth term, r to the third, and so on, okay? And so if all we have is the common ratio and the initial point, we can find the entire sequence based on this right here, which derives from this. So I hope that's not too complicated. I just wanted to have a video to go over these definitions. We can try finding the 12th term of the geometric sequence 5, 15, 45, ... so on. I'm going to do that over here real quick. So we know that our initial term, a sub 1, is going to be 5. Our common difference can be represented by the second number divided by the first number, as long as it's the same as the third number divided by the second number, and so on. So let's check. We'll take the second number divided by the first number. 15 divided by 5 is 3. Now let's take the third number divided by the second number. 45 divided by 15 is also 3. So that means that r equals 3. And we're trying to find the 12th term. So that means that n equals 12. So if we have these three variables here, I want y'all to finish this up, plug these into the formula, and find me the 12th term. Okay? So I'll probably just use a text box for this in the Desmos activity. So why don't y'all find the answer using these variables, find the 12th term of this geometric sequence. All right? Thanks for sticking through. We're going to get through this chapter. I'm going to try to explain everything super well. We're going to use class time well. And if you're not feeling good about this, we'll make sure that we use class time to understand it even further. All right? So like I said, thanks for sticking with me, and I'll see you on the set.